All right, this is a continuation from yesterday of solving systems of equation using elimination. So we'll put the steps down. I'll pause so that you can have a chance to copy those down to help you remember the order in which you want to do things. First, we talked about putting things in standard form. So now you know the difference between an equation in standard form and function form. So this has your coefficient of x plus your coefficient of y is equal to a constant c on the other side. So both variables are on the left in standard form. When you do this, one variable should be pretty easy to eliminate with either addition or what we're going to look at today is possibly subtraction. You solve for the variable that is left. Go back and use the found variable or your new variable in step 3 to find the second variable, and then always check that it is a solution in both equations. So let's look at this first example. You can tell that the second equation needs to be rearranged a little bit so that they are both in standard form. So if we subtract 2y from both sides, we rewrite the second equation to be 5x minus 2y equals 1. So that was step 1. Step 2. In this case, this is unlike what we did yesterday. We're not going to add the equations because you notice that we have the same coefficient of x, which is 5, but by adding them, we haven't eliminated anything, right? So, but if we could subtract them, meaning, and when you subtract, look what happens right here, all right? It's kind of like distributing a -1. So you take that, it changes the sign of every term. So we get the negative 5x, now we get a positive 2y and a -1. Okay, so we distributed a -1. I want to point out that in step 1, this really should be 11. That was just a typo for that to be left off. So if you look at our original equation, 5x plus 3y equals 11, so we'll try to keep that the same. So we've distributed the -1. And now we can eliminate the x term. We can take 5x minus 5x, which is 0, and combine 3y and 2y to get 5y. 11 plus -1 is 10, and so 5y equals 10. We can solve for y. That's equal to 2. Take that back into one of the original equations, substitute in the y, and solve for the x. So if we take it into the first equation and we substitute in a 2 for y, we get 5x plus 6 equals 11. Subtract 6 from both sides, and then x is equal to 1. So now we have the point or the solution. We have 1, 2 is the solution for this system of equations. And then you check your work. Another part. So this is just going to summarize everything that we've done. Okay. Let's try another one. Equations are already in standard form, so you don't have to write this down. This is very similar to yesterday. We are just adding the equations. We did examples like this, so I would, recommend we'll just go through this one quickly so we can get to the next example, which does multiplying, but it will be here on the PowerPoint for you. So we're eliminating the y. We have substituting it in. The solution is 2, 8. Check your work. All right. I'll skip this for right now as well. Now, and I'm also going to skip this one, but I will go ahead and click through it. Okay, another example that we want to look at is having to use multiplication. So far we've done this. We've done graphing, substitution, elimination, and one step further is to find the least common multiple to actually change the coefficients to be the same. Okay, so we already know this. You don't have to write these down. We're looking for the variables that have the same coefficient, and you solve for the variable. Okay, so put them into standard form. They already are. Determine which variable to eliminate, and in this case, none of the variables are the same. So what we can do is find the least common multiple of each variable. So if you look at the x's, 2x and 3x, we look for the least common multiple of those two numbers, which is 6. So if we could change these equations somehow so that they are both 6, or we look at the least common multiple for the y's, which is 2. And in that case, I only have to change one equation and look also how it's a positive 2y. So if I can somehow get the second equation to be a negative 2y, and I can by multiplying the whole equation or distributing a positive 2. So that's what we'll do. So we look at the least common multiple, and we can see that it's obviously easier to just change the second equation than to have to change both. Sometimes you will change both. We'll look at an example too. So 2y, you only have to multiply the bottom equation by 2. So let's do that. So write these systems down as an example. So you have 2x plus 2y equals 6, and 3x minus y equals 5. Now, just like we distributed that negative sign when we subtracted, let's distribute a positive 2. So we'll take 2 times 3x, which will be 6x, 2 times negative y, which will be negative 2y, and 2 times the 5, which will be 10. So these become the equations that we actually want to use elimination, and we can use addition because the signs are opposite for the coefficient of y. So if we eliminate the coefficient or the variable y through addition, we have 2x plus 6x equals 8x, and 6 plus 10 equals 16. Therefore, x is equal to 2. We can substitute that back in and find y. Plug it back in to find the other variable. So y is equal to 1. Your ordered pair or solution for this system will be 2, 1. You could then substitute it back in to check. Okay, checking your solution then would be to use substitution. So it does add one more step. You have to put it in the right shape. What about this one? We'll do one more example and then we should be ready to work. So we look at the multiples. They're already in standard form. And the least common multiple for the x term would be 4. And the least common multiple for the y term would be 12. So remember then, this kind of shows you too that if we multiply the top equation by 4, we'll end up with a 4x, and we still can't eliminate that other 4x. So somewhere along the line we'd have to do some kind of subtraction or distribute a negative. But if you could do it in one step by multiplying the top equation by -4, you can make them inverses. So you get a negative 4x minus 16y equals negative 28. Now we're adding, so we've eliminated x, a negative 16 and a negative 3 is a negative 19. Negative 28 plus 9 is negative 19, therefore y is equal to 1. And x is equal to 3. So 3 comma 1 is your ordered pair.